My name is Bruce Momjian. I'm one of the Postgres core team members. I've been working with Postgres for 24 years now, so a long, long time. I want to talk to you about a little bit about Postgres, and it's great to go after Matt because I'm going to build on what he said. These slides are online, my website right here, momjian.us. There are a couple dozen presentations there and hundreds of blog entries, mostly about Postgres, but some other things as well. So feel free to take a look. What I want to talk to you about in the next 30 minutes is a concept sort of building on what Matt said in terms of why is open source such a powerful force in the software industry and why it's fundamentally different than the traditional proprietary software that we've come from. So I want to start out talking about the concept of forever, kind of a funny way to start. And then we're going to get into exactly the point I was talking about, the concept of the software lifecycle. You don't hear about it too much, but I'm going to kind of piece that together and give you an idea of how software in the open source has a different lifecycle than the proprietary examples. And I'll give you some specific examples, kind of interesting. Then we'll talk about open source adoption. There was an interesting study done a couple of years ago and give you some key points there. Then we'll talk a little bit about Postgres innovation. I'm not sure how much we're going to be able to get into, but I'll highlight the big things, and then we'll talk a little bit about the community structure. So first, let's talk about forever. What does it mean for software to live forever, right? I mean, forever, that's a long time, okay? We're talking like billions of years so far. We don't really know how many more billions of years we have. But as you can see there at the bottom, the number of years that we've been digital is pretty small. So is Postgres going to live forever? Probably not. But it is, again, I've been with it for 24 years. It started out for University of California 34 years ago, and it probably has a couple more decades to go, I think. So it's not going to live forever, I would say, but it's going to be a long time. So just to give you an idea of the history of digital stuff, Jacquard Loom really being the beginning of that. But again, ENIAC actually started here in Philadelphia, which is where I'm based, in 1945, sort of the first programmable kind of computer. And then, you jump forward, 75 years or so, 85 years, and you get to where we are today. So again, databases really only in that last 50 years or 40 years or so. So again, not a whole lot of history there, but just to give you an idea. So software life cycle, what is that? This is actually a picture of a computer that I used when I was in high school. So anybody recognizes it, you're probably my age. But again, hardware has really not lasted a whole lot of time, right? I saw one of these in a museum recently. I think it was in Santa Clara. But there are not a whole lot of old hardware around. But software, that's different. It's a fungible thing. It's malleable. It does last, can last a considerable amount of time. So let's talk about proprietary software and the typical life cycle that proprietary software goes through. And I'll kind of make some examples as I go, but effectively, almost all proprietary software starts with some kind of innovation, some kind of idea that we have a new idea for the market, we have a new solution for customers, something that doesn't exist anymore. We're going to innovate. We're going to fund that innovation. We're going to spend 6 months, 18 months, put together a development team and develop some kind of product. Then you have your first sale. Then you go into phase 2, which is market growth, where you're basically trying to figure out, how does my product fit within the market? What kind of things can I do to increase that, and so forth. And that can last a while. It might last 6 months, it might last 6 years. But then when getting to item 3, you basically reach a point of saturation where there might be another vendor in the market who you're not able to really surmount. But you've pretty much grown as much as you're going to grow. And then you enter, excuse me, stage 4. and that's maximize profits, minimize costs. So this is the point at which no matter how much money you sort of pour into development or innovation, you're really not going to move the needle. You've kind of saturated as far as you're going to go. So you maximize profit, you minimize costs. And usually what that means, your prices go up, development expenses go down, you have fewer developers, you spend less money on support, you're less concerned that customers are happy or talking positively about you. Okay. And you may be in profit maximization mode for a while. I could list off a whole bunch of companies off the top of my head. They're in that profit maximization mode. And then you get to stage number 5. Stage number 5 is effectively where you've shut down development pretty much. You may be doing minor bug fixing. You're not adding any features and you're not adding any innovation. And this can go on for a while, until you get to stage 6. And stage 6 is the point at which you can't make enough money to even stay in maintenance mode anymore. And the software, because it's not open source, just disappears. And if we think of a lot of really cool software we used when you were younger, typically if it was proprietary, as soon as it left maintenance mode, it's gone. You can't improve it. You can't do anything with it. It's kind of the whatever source code you had is disappeared. And that product or that game or whatever just isn't available anymore. So I know I'm talking about end of life. Maintenance mode, there's a lot of products in maintenance mode. We used to say computer associates. Associates was where software goes to die, CA effectively, because they sort of specialized in bringing in software that was in maintenance mode and effectively just maintaining it and getting revenue that way. A lot of the proprietary databases now are kind of in stage 4, right? They're really saturated in their markets. They may have competition from open source, but again, they don't see development or treating their customers better as a way to grow things. So they're just kind of riding out that stage between stage 4 and stage 5. Some software now, like maybe Informix, Sybase, are all in that stage 5 area. In the 90s when I was a developer, Ingress and Informix and Sybase and DB2, were all, Oracle, were all in that market saturation, trying to compete against each other. Now they're all in that 4 to 5 stage, I would say, in terms of the proprietary software relational databases. Now, looking at open source, it's kind of a different case. You don't start off with innovation necessarily. You may start off with innovation, which is a lot of cases. You may start off just trying to gain parity with a proprietary offering. Okay. So again, it might be one of the two, but you don't have any funding, so you don't really have like time limits. You don't have requirements of trying to get to market in a certain time. It's a different dynamic, right? Then you go to market growth, and market growth can happen to a certain point or not happen to a certain point. But there's no sense that you saturate the market because, like, what do you do? Like, there's a bunch of open source tools that have kind of saturated the market, but you don't have any profit maximization because typically in open source, pure open source, where it's not controlled by a company, there is no profit maximization. You just keep innovating, or you decline, or you innovate, but you don't have another target that's going to push you away from innovating or away from investing because you never invested in the beginning. You never had this sort of goal of profit maximization. Oh, we got to pay for all the investment we did during our innovation phase. None of that enters into it. And then again, if it declines, the source code is always available because it's open source, right? So it could decline and somebody else could pick it up and then it could get more popular again. Now you might think that's a silly concept, but in fact, when I started with Postgres in 1996, it was sort of in maintenance mode. There's one person maintaining it. Regular releases weren't coming out regularly. Regular It wasn't being patched with patches applied and released. So when we started in '96, it was already 10 years old at that point. It had left the University of California, Berkeley. There was one or two people maintaining it. But again, the source code was available, so we were able to build on it. So again, the concept of the previous slide where the software, once it goes into maintenance mode, just goes away. That does not happen with open source. And again, that can be another way where software continues to live. I'm gonna try and explain this slide in 30 seconds because I think it's an amazing example of a mix of open source and proprietary together. 1994, company puts out a game called Falcon 4. Anybody my age or my son even loved the game. Okay. 1998 is the final release. 1999, game development ends. 2000, somebody leaks the source code to the game. So the source code gets out of the proprietary thing. 2003, an open source community gets created to generate modifications of the game. 2005, a company takes the mods and makes a product out of it called Allied Force. Okay, 2015, a company gets the license for that and republishes it. And then in 2015, again, the open source community makes more minor releases to the new proprietary release. So again, great example, again, the URL there at the bottom of software going in and out of open source, basically almost seamlessly is kind of interesting. Let me give you just a visual of exactly how things are different. This is a flow of what proprietary looks like. You have on the left, developers in a company, primarily driven by sales and marketing. And then on the right, you have users. And you can see there's a very defined flow of when users see what happens in development and what development sees from the users. And this development model is so inefficient that effectively open source is able to produce better software just by improving the model, not by having more resources necessarily, but having a better way of interfacing between developers and users. Because in open source, you have users and developers at all steps of the process. Postgres is putting out a beta for Postgres 13 this week. And again, we're in that fourth box there where we're going to have beta testing by users, talking to developers, basically fixing things in real time, 24 hours a day, getting to a final release. But again, we've had our developers, our users involved in the development process through feedback, through testing, through ideas all the way back to the feature being proposed. So again, this kind of efficiency, I think, is what makes open source just so tremendously powerful. When I started with Postgres, we were effectively down here at the bottom of the red. But what I learned from starting in 96 is that no matter how inferior we might be to features, performance, and reliability compared to closed source software, if we had a growth curve that was steeper, we would eventually overtake closed source. So even though you start lower, but if you're climbing faster, you effectively have the chance to exceed the closed source products. And there's a lot of ways in which Postgres has exceeded and is above that blue line today. You might think I'm just making this up, but effectively we already have some major operating systems that used to be best of breed, that used to be the go-to for enterprises. HPUX, AIX, Solaris. I used HPUX a lot when I was a consultant in the 90s. It was the go-to operating system for our hardware. But effectively, Linux retained parity and then innovated beyond them. People are not using Linux necessarily today because it's cheaper. The ability of Linux is just so far superior to these. And of course, Solaris is now end of life, as was announced, I think, 2 years ago by Oracle. So again, you can see that end of life process kind of starting even at the operating system level. At the database level, again, same thing. The ones here in bold are currently being actively developed, the first three. The last three are in maintenance mode. As far as I know, they're not gaining market share. There's no new features coming in. And again, I think even the first three are kind of some sense struggling to understand what the new open source competitors are, what the non-relational competitors are, and they're certainly not growing market share. They're really try to struggle. Whether they're going to end up like the HPUX Solaris, I don't know. I would probably think eventually they will, but maybe not. It's hard to say. But again, you can see, I wouldn't have guessed that these major operating systems would be, in maintenance mode today, but they are. So again, interesting parallel there, I think. Another great advantage of open source is that instead of having a company drive development in one direction, because you don't have a company, you have a whole bunch of distributed teams all over. They're innovating in every direction at once. So you're getting in every major release performance stuff, cloud stuff, ease of use, scalability, usability, developer features, all at the same time. And that's just a tremendous opportunity for open source. So when does software die? Well, proprietary software dies when the owner of the source code no longer profit from it. Pretty clear, right? Unfortunately, it declines long before death due to profit maximization, that profit maximization stage that I talked about. Open source doesn't die in the same way. It remains active as long as it serves a purpose. It can be resurrected. As I said, in 1996, we absolutely did that. So ideas don't die as long as they're shared. Ideas are shared as long as they're useful. Proof of that, my children in college, I have 3 who finished, 1 and still in college. They're learning the same books I learned when I was in college. They're reading Plato, they're reading all the old classics because those ideas are still shared, because those ideas are still useful. And again, Postgres will live as long as it's still useful. Let me talk a little bit about an open source adoption survey. I think there's a couple big takeaways you can get from this. Again, feel free to look at the slides, but again, they did a survey. What things, once people went to open source, the Black Duck software went back and surveyed those people, and they asked them, what are the advantages of open source? And the amazing thing to me is number 5. In almost every case, people went to open source because of cost advantages. But what they realized once they were using open source is that there were 4 things that were more useful to them than the cost savings. But they didn't see those advantages until they got open source into their enterprises. Specifically, competitive advantages, innovation. Again, great, open source really focuses on innovation. It's not focused on profit maximization, obviously. So innovation is kind of it. Freedom from vendor lock-in. There's no value to locking people into open source. There is a value to locking people into proprietary. I think we had, Peter Zeitzig talked about that this morning. Quality of solutions, reliability, of course, and the ability to customize and fix were all more important than even the cost. And then there were 6, 7, 8, 4 other advantages that they found. So again, it's sort of like you go to the restaurant because of the coupon, but you end up returning to the restaurant later because the food was great. It's the same kind of thing. What drove people to open source is not necessarily the major advantage they end up getting from it. And this is one of the reasons that people keep going and going and going to open source. It seems like it is an unending trajectory of the software industry. Again, just a quote about how great it is. Databases in 2016 at least had become much more popular as a reason to use open source than previous. Again, database seems to be a little lagging in terms of adoption for open source in enterprises, but this year and certainly the past recent years, we've seen an incredible amount of adoption. This slide I love to talk about, but I'm kind of limited in time. Effectively, when you might want to study it later, when you're talking to somebody about adopting open source, there are typically three teams you have to address: the management team, the administrative team, and the development team. And each team sees a different advantage to open source. So the managers may see cost or vendor lock-in as an advantage. The administrators see quality and interoperability. Developers see innovation and speed of development. And when you're talking to somebody, you should probably use the language that that team is interested in when you're talking about open source. Talking about cost to developers typically doesn't have as much impact as talking about how quickly they can innovate using your solution. Let me talk specifically about Postgres. Picture Joe Selko here. If anybody knows him, the big SQL guy with our Sloanic mascot there. So Joe Selko, really, again, one of the founders or sort of the great teacher of SQL, but SQL goes way back before Joe. E.F. Codd in the 70s sort of designed relational theory. Michael Stonebreaker in 1986 started the Postgres development project at Berkeley. He is an advisor to Enterprise DB, where I'm an employee. And one of the innovations that Michael Stonebreaker had was the idea of extendability, the idea that a database didn't have to have fixed data types and fixed programming languages and fixed indexing methods. So it's an extendable system. And Postgres has built on that innovation in an amazing way in the 24 years that I've been with the project. For example, if you need a new data type that deals with ISBN numbers or UPC numbers, you can literally type what I put in red here, and you automatically get a new, 8 new data types that understand book numbers, magazine numbers, music numbers, and UPC codes. If you need a server-side language, you can load in any of these languages. Postgres comes by default with only a few of them, but you can get more of them. So again, if you want a server-side language that matches your application language, you can do that. If you need to do NoSQL work, or particularly something like GIS, or full text search, or geometry, or JSON, there are flexible indexing methods that are designed specifically for non-relational workloads. GIN, GIST, SPGIST really are great when you're looking at non-linear data. B-tree is great for linear, right? But when you start to look at 2D points, when you start to look at JSON and full text search, B-tree doesn't work very well. GIN, GIST are excellent for that. BRIN, great for data warehouse. Again, another extendability. Full text search, as I said before, is part of Postgres, part of the entire transaction engine, part of the whole indexing engine. It is integrated. It's not like a separate thing that sits on the side. Here's an example of a full text search query. NoSQL, we do support that. Again, integrated into Postgres, mixing non-relational and relational data, relational and non-relational queries in the same application, full transaction semantics, specialized indexing methods, operators, and functions to make that useful, all is part of Postgres. Here's an example of a JSON query. Range types, I can't even get into this, but it effectively takes a start and stop field, merges them into one field, and then allows you to do very sophisticated indexing on that. That's an example of a range query. Geometric types, points, lines, circles, very popular with GIS. There's a geometric query right there. GIS, again, an entire geographical information system, which plugs into the Postgres engine, developed independently. You just type create extension PostGIS, and it loads it into your existing database. Incredibly great example of how extendability fosters innovation. That's an example of GIS query. Foreign data wrappers. Postgres has the ability to access over 100 different types of data. Uses the SQL Med standard. You can read-write data. You can do joins, sorts, aggregates. Here's an example. You can You can reach out to Oracle databases. You can reach out to MongoDB. You can even read Twitter feeds in Postgres. So again, the ability to interact with other data sources, a great use of extendability and innovation in the Postgres space. Data analytics, we support all of these features. So if you're used to having a separate data analytics engine, you can do all the analytics inside of Postgres, either in your primary database, or you can use streaming replication, create a separate server or multiple separate servers that do data warehousing, do your OLTP on your primary, and do all of your data warehouse on these streaming replicas, not interfering with your primary workload. So again, you can either do it on the same machine or in different machines, works really well. But again, the same database, the same schema, no need to keep them synchronized, happens automatically. A really great way of sort of mixing OLTP and OLAP in the same system without having to bring in something that needs maintenance to keep it synchronized, old data, schema change, synchronization, none of that is necessary here. Sharding, again, a way of moving Postgres to multiple shards. That's a multi-year effort. We're still working on that. So what is the Postgres community structure? How does this all work? Postgres is a BSD licensed piece of software. That effectively means it's free for use, any use, including proprietary use, and is available effectively forever. As long as there's a copy around, that license is available. The development and the leadership team are diversified, both geographically, culturally, and also multi-company. So I could reel off all the companies that support us around the globe, but suffice it to say there are dozens of them. We are very thankful to the help that they give us, both in terms of funding some of our developers, giving us patches, helping with conferences, promoting Postgres. It's a great environment to be in. So 32 years in, we have 22 years of annual major releases. Again, I said our beta for 13 is this week. Typically 180 features every major release, quarterly minor releases. And if you're curious about what's happening in the Postgres community world, there is a PG Life website there at the bottom, which will show you all the blogs, all the most recent email, the most recent tweets. That part of the bottom is the IRC channel feed, the last 20 or 8 IRC messages, so you can get an idea of what's going on. Very vibrant community, never sleeps. So really excited to do that. Thank you so much. Really a pleasure to be able to talk to you about, will Postgres live forever? Probably for a long, long time, because of the reasons I've talked about, because of the way that the open source life cycle works, and because we are a community that continues to sort of feed innovation and run it through a lens, I would say, that focuses it on providing the best relational solutions for today's workloads, as well as those for enterprises. So thank you so much.